The lesson topic for this video is writing equations for graphs of radical functions. Okay, so this lesson we are going to do the opposite of what we have been doing, which is taking an equation and graphing it, and now we are going to take the graph and write the equation. Alright, so this first one we have to look at and realize that this is a radical function of which type? Well, the answer is this is a cube root function, right? Because it curves both directions. So we have to make sure, it's super important, that you do not forget that it's going to be y equals some value a in the cube root of x minus h plus k. All right, so don't forget that cube root there when it's a curve that has the inflection point. Cube root. All right, so now what we can do is we can put in the values that we know in this equation. Okay, we know h and k for cube root function is the inflection point. To be honest, this is sometimes tricky for some students to find that point of inflection, but if you look here, the curve is changing right in this region here. So it's curving this direction here, it's straightening out, and then it's curving this direction. So where is that inflection point? Well, it's right in the middle of what looks kind of like a vertical situation right here. So it's right there. Okay, so this is at 2, 7. 2, 7. We can write that down for our inflection point is 2, 7. That point. Okay, so that's going to go in for our h and k. And then that is actually all we know right now that we can put into our equation. So I'm going to actually go ahead and do that. So we're going to write y equals a times the cube root of, now you have to be careful here, if our x value is 2, we're going to write x minus 2, right? So x minus 2, whatever, blue. And then our k value is 7, so plus 7. All right, we put in the 2 and the 7. All right, so what we need to do now is we need to find out what the a value is. And we've done this with other types of functions before. And hopefully you remember what we need to do is we need to fill in a value for x and y, and then solve for the remaining variable, which is a. So where do we get a point that is x and y? Well, let's remember that any point on the curve we can use for x and y. But typically there will be one shown for you, and please do use that one. So in this case, this is 3, 5, that point right there. So we're going to put a 3 in for x and a 5 in for y. All right, so y we're going to put in a 5. Leave a as it is. Cube root of a was 3, so 3 minus 2, and then plus 7. All right, so we're going to simplify this to solve for a. We're going to leave the 5 alone, and we're going to leave the a alone. And for now, we're going to leave the cube root alone. 3 minus 2 is 1, and then we have plus 7. Again, the plus 7 is not under the root. Don't forget that. The root ends here. Now we need to take the cube root of 1, and you can do that in your calculator, or you can think to yourself, what number multiplied by itself 3 times is 1? And the answer in this case is the number 1. So now we have a times 1 and then plus 7. Remember to solve for a here, we can think of this as 1a. So we're not going to take and deal with this. We're not going to add 1 plus 7. Please make sure you do not do that. In fact, it might help some of you remember how to solve this by simply switching the a and the 1 around. So we have 1a instead of a times 1 plus 7. So we're just going to subtract 7 from both sides to solve for a. 5 minus 7 is negative 2. And so 1a is negative 2, or in other words, a is negative 2. All right, so now that we've found a, we have to write our final answer. Our final answer is the equation for this curve right here, which will be y equals the a value, which we found to be negative 2, times the cube root of x minus 2 plus 7. And as always, since we have the technology, you can type this equation into your graphing calculator and graph it to make sure that you arrive at the same graph that you should have. Okay, so we're going to do the same thing we just did, but with These two graphs, these are both examples of what type of radical function? Well, they are square root graphs. They have a starting point and they curve in one direction. This one's going up and to the right, and this one's from the starting position is going down and left. So you have to be careful. The thing that people forget with the cube root function is to put the cube root in, the 3. And the thing that people forget with the square root functions is that we need to first think about which direction the curve is going. Okay, if the curve is going right, whether it's up and right or down and right, our x is going to be positive. But if the curve is going left, we know that the x has to have that negative that has been factored out. Okay, so we need to be careful with that. So let's go ahead and try these two examples, keeping that in mind. So first of all, we know we have an equation that is of the sort y equals a times the square root of x minus h plus k. And that's true for both of them. And it might help some of you to actually write that general function down right away. All right, so let's find the starting point of this first example. The starting point is right here at 1, 6. All right. We're going to go ahead and put that into our equation. Y equals a times the square root of, and again, the 1 is positive, so it's going to be x minus 1 and then plus 6. All right, and now we are going to put in a number for x and y so we can solve for a. This point right here is given to us at 5, 8, so we're going to put that value in for x and y. Y is 8. We're going to leave a as an a, and we're going to put a number in for x, and that number is 5. We're going to simplify and solve for a. So 8 equals a times the square root of 5 minus 1, which is 4, plus 6. So 8 equals a times the square root of 4 is 2 plus 6. Again, if you rewrite this, you're going to make less mistakes probably. A times 2 is the same as 2a. All right, we're going to subtract 6 from both sides. We're going to get 2 equals 2a, and then we can divide both sides by 2. All right, divide by 2. Sorry, that's going to be hard to do on my screen here. You can't tell why, but anyways, whatever. 2 divided by 2 is 1, so we have a equals 1. All right, when all is said and done, we got to finalize this problem by writing our final answer. Y equals the a value is 1, which we wouldn't need to write then, but we can. X minus 1 and then plus 6. And again, make sure that plus 6 is not inside that square root sign there. In fact, we could probably just erase some of that. All right. Again, you can graph that on your graphing calculator and make sure you have the same graph. All right, so what we have to do on this next one, and this is the one that'll get some people, is since it's curving left, okay, we have to pay attention to that x value. All right, so what I'm going to actually do is I'm going to change this function a little bit since it's curving left, and I'm going to say y equals a times the square root of, I know I'm going to have this negative here, and I still have x minus h and then plus k. All right, our starting point, as we can see right here, is at 5, 4. We're going to put those two numbers in for h and k. So y equals, leave the a, square root negative x minus our h value, and that's our x value of our starting point, which is 5, right? So we're going to put a 5 here, and then plus 4. We're going to use a point for x and y, so this point right here is shown to us. That's at -4, 1. All right, so we're going to put a 1 in for y. We're solving for a. We're going to put a negative 4 in there for x. And then we have the plus 4 out here. All right, so we'll be careful when we simplify inside that root. So 1 equals a times the square root of, I'll just leave this here for a minute, it'll be negative, and then negative 4 minus 5 is negative 9. So 1 equals a times the square root of negative 9, which is 9, plus 4. The square root of 9 is 3, so a times 3, and then we have our plus 4, or in other words, 1 equals 3a plus 4. If I subtract 4 from both sides, I'm going to get negative 3 equals 3a, and divide both sides by 3, and we get negative 1 for a. Okay, so we're going to write our final answer as, oh, it's not going to work for me, y equals negative 1 times the square root of negative x minus 5 minus, nope, plus 4. There we go. Okay, so here's one last example, and what I'm going to suggest is that you pause the video and then check back to see how you did. Now, one thing you have to be careful of on this one is that our starting point is over here where x is negative and y is negative, so you will have to keep that in mind when putting those values in for h and k. So give it a try, check back to see how you did. Okay, and this is what you should have for your final answer. Y equals negative 1 times the square root of x plus 1 minus 7.